Hi, and welcome to this Dynabrade Best Practices video. My name is Pete Maduri. I'm the Dynabrade Corporate Trainer. Today, we're going to look in depth at swirl marks in wood sanding. What are swirl marks and how can they be avoided? You know, in general, wood sanding is oftentimes viewed as a pretty simplistic process where the operator doesn't need much training. However, this is not the case. Let's think about it. We're relying on an operator to manually remove defects and get a consistent finish. What's more, they're oftentimes doing this in high production settings. The goal of this video is to establish a checklist that you as the distributor can walk into an end user and confidently diagnose some of the common problems that may lead to swirl marks. So first, let's answer the question, what exactly are swirl marks? You've probably commonly heard them referred to as pigtails, fish hooks, or half moons. Swirl marks are superfine scratches on the work surface visible to the naked eye. They are a defect that require rework all the way from smaller shops up to larger industrial settings. This visual shown here is a good representation on what we would see when we refer to swirl marks in woodworking. There are a multitude of different variables that can lead to unwanted swirl marks. However, all these variables can really be broken down into four main categories. These four categories are: number one, damaged backup pads; number two, a poorly maintained orbital sander; number three, the quality of the compressed air system and air delivery; and number four, proper sanding techniques. Let's start out by talking about backup pads. Oftentimes, backup pads are overlooked as a potential problem when an operator runs into these unwanted swirl marks. However, it's usually one of the common causes. There is a direct correlation between the backup pad and the finished product. Let's look at taking a backup pad off an orbital sander. With Dynabrade, it's real easy. All we're going to need is one 26mm wrench. We're going to fit that wrench in between the bottom of the housing and the backup pad. It will rest on a flat. We'll then turn the pad in a counterclockwise motion, and it will unthread from the tool. Just like that, our backup pad is off the orbital. When speaking to pad failure, there are two common problems that take place. Number one is the foam breaking apart, and number two is the abrasive stops sticking to the backup pad. When the foam comes apart, it is called a cohesive foam failure. It is due to age, exposure to chemicals, or poor material bonding. The following is a good visual representation of this. When the foam pulls away from the backer, it's called an adhesion bond failure. The foam itself stayed together, but did not adhere to either the interface material or the fiberglass pad backer. This is pictured here. The second potential problem we mentioned were the abrasives not sticking to the backup pad. It's usually due to melted hooks from overheating during sanding. If it's PSA or stick-it, there is usually contamination between the pad facing and the abrasive. Notice the visual here of the melted hooks. This was most likely caused by excessive pressure being exerted during the sanding process and excess heat. Regardless of which backup pad issue we're dealing with here, the main point is the pad will not be able to sit flat on the work surface, we will not be able to sand evenly, and the end result is going to be surface defects. We're going to see those swirl marks. On a side note, we need to ensure that our backup pads stay clean. If we are using a PSA or vinyl style backup pad, we need to remove the PSA disc at the end of the workday. We also need to ensure that there is no glue or adhesive left behind. If anything is visible, we need to remove that. Again, if anything is on the pad, it will not be able to sit flat on the work surface. If we are dealing with a hook and loop style pad, we need to constantly clean the hook and loop or the Velcro. We can do this with compressed air by just blowing the pad off. We should be blowing the face of the pad off routinely through a standard workday. Dynabrade has several options when it comes to pad diameter. We offer orbitals in 3-inch, 3.5-inch, 5-inch, and 6-inch. One common question we often receive out there in the field is, can we take a 5-inch pad and put it on a 6-inch orbital, or a 6-inch pad and put it on a 5-inch orbital? The answer to that is no. The tool will vibrate excessively. Why? Dynabrade pads are weight mated to the tool. So for example, a 6-inch pad weighs 130 grams, a 5-inch pad weighs 100 grams. So if we were to take a 6-inch pad and put it on a 5-inch orbital set up for a 100-gram pad, we'd essentially be adding an extra 30 grams. The tool would be out of balance, and again, it would result in excessive vibration and an unwanted finish. We would have swirl marks. Another common cause of getting swirl marks is not properly maintaining your orbital sander. Air tools in general can be viewed like an automobile. They need to be maintained. When an orbital sander is made at Dynabrade, it is made to run at approximately 12,000 RPM free speed. Under a load, it maintains about 10,500 to 11,500 RPM, depending on the model. If the orbital sander is not properly maintained, it will not be able to run up to this speed. This will often result in defects, and again, the end user will get those swirl marks. Looking at proper lubrication, if we are doing it manually, Dynabrade recommends 2 to 3 drops of air lube into the inlet of the tool 3 times a day on a standard shift. This would be once in the morning, once at lunch, and then most importantly, at the end of the workday. The idea here would be to put 2 to 3 drops into the tool and then free speed run it for approximately 10 seconds. We would be coating all the internal components and protecting it. Dynabrade recommends 10-weight non-detergent oil. Dynabrade's air lube is a great option. Dynabrade also offers filter regulator lubricators, or FRLs. These are a great option to keep the tool maintained if the operator does not want to worry about doing it manually. Continuing with the idea of properly maintaining our orbital sander, one thing we want to ensure we avoid is not allowing any debris into the air motor of the tool. Here's one thing I constantly see when I'm out in the field. Okay, what was wrong with what I just did? While the sanding technique was fine, which we'll get to a little later in the video, notice there are other tools that I was not using laying around the work area. With this non-vac tool, I was creating a cloud of debris. That debris was most likely going into the other tools, in the inlet, and actually getting inside the air motor. Okay? Any type of debris that gets into that air motor is going to cause premature wear. So we want to avoid doing this. The other thing I constantly see out in the field is I will see a customer take a blowgun. This is one of Dynabrade's inline blowguns, and they'll actually blow air into the inlet of the tool. We never want to clean off the inlet of the tool by blowing excess air into the tool. Oftentimes out in the field, this is done with the use of a blowgun. That will force dirt and debris into the tool. Remember, before the tool actually fails, it is going to slow down, and if the tool is not running to optimal performance, it's going to run slow and again leave those swirl marks. One last thing I'd like to touch on in regards to properly maintaining our orbital sander are the muffler inserts. Dynabrade takes great pride in manufacturing some of the quietest industrial power tools on the market. For this reason, they are all made to spec with muffler inserts. We should never take these muffler inserts out unless we are replacing them. Oftentimes I go into a customer, and if they think the tool is not running to speed, they'll take the muffler inserts out to generate a little more power. More noise does not always equal more power. If the tool, again, is not running to optimal speed, it will create defects, and again, the customer is going to be dealing with those swirl marks. We need to continuously monitor the muffler inserts and replace as needed. The next potential problem when dealing with swirl marks is the compressed air system. We are concerned with the air system all the way from the compressor to the actual air tool. For it to be efficient, everything must be adequate. The first two things I'd like to discuss in regards to air delivery is air pressure and air volume. These are two completely different variables and should be treated as such. Without adequate air pressure and air volume, the tool will not run to optimal performance. Let's first begin with air pressure. For the most part, all Dynabrade tools are rated at 90 psi. This is the reading we need to see while the tool is running. Now let's take a moment and focus in on air volume. Dynabrade supplies MegaFlow plugs and couplers. There is a substantial difference between these MegaFlow plugs compared to standard industrial. Looking at a standard industrial 1/4 inch fitting, it only allows approximately 25 SCFM into the tool. On the contrary, a Dynabrade 1/4 inch MegaFlow plug allows a full 76 SCFM into the tool. To ensure our air tool is getting adequate volume, we should always stick with the Mega plugs. Now let's spend some time looking at the air hose. We want to ensure that the air hose is as short as possible within reason, definitely under 20 feet long. Any longer than this is when we begin to reduce the amount of airflow tremendously. We also need to look for any additional couplers or restrictions along the way. Anytime we see one of these reducers, we again are reducing the amount of airflow. Another thing to avoid, both coil hoses and hose reels. The fourth and final point we want to focus in on in regards to getting swirl marks is operator technique. Alright, so sanding technique number 1. We always want to start the orbital on the surface and stop off. I'll demonstrate proper technique first. So the question is, why do we want to start it on the surface and stop off? Well, the answer is very simple. If we get the tool running and then meet it up to the surface, it's likely going to gouge the surface because it's not going to be hitting it in a uniform manner. This, again, are going to lead to swirl marks and defects. The other thing is, if we stop the tool on the surface, as the tool slows down, it's likely going to dig in and gouge the surface. That's exactly what we don't want to do. So again, we want to start the tool on and stop the tool off. The next sanding technique we want to abide by is we always want to work with the orbital sander horizontal and flat on the work surface. We never want to work up on angle or up on edge. I'll first demonstrate the correct method. Again, starting on, stopping off, but again, we want it flat with the surface. Again, we would never want to work with the orbital up on edge. This is likely going to create gouges and wild scratch marks. That is exactly how we would not want to operate an orbital sander. We do not want to exert excessive pressure on the orbital sander. We really want to let the tool do the work. Especially with Dynabrade orbital tools, that extra power is built in. We can really back off and let the tool do the work. Our engineering team has found that it is optimal to put approximately 5 to 6 pounds of downward pressure on an orbital sander. Remember, most of these sanders weigh somewhere in the neighborhood of 2 pounds, so we're only exerting a few pounds of actual pressure. I'll first demonstrate how not to run an orbital sander exerting excessive pressure on it. Right away, you can hear the tool bog down and it's not real happy. I've also noticed a lot of vibration in my wrist as I was white-knuckled. That's not the way we want to run an orbital sander. That will remove material too quickly and will definitely lead to some swirl marks as well as surface defects. I'll now demonstrate an optimal pressure, again, letting the tool do the work. You'll see it run at a nice even speed, and I'll accomplish just as much work, but avoid those swirl marks. Okay, the next thing I want to talk about is the proper sanding pattern. That's really dependent on the end user and their desired finish. There's really two answers here. If we're working with an end user where they're trying to ensure proper coverage and the final finish isn't quite as vital, we're probably going to recommend a north, south, east, west sanding pattern. So what I mean by that, on this piece of wood, we would sand north and south and then we will come back and go east and west. This would ensure proper coverage. I'll demonstrate that now. Now, what if we were in an end user where the final finish was very critical, like we see in a lot of the higher end woodworking shops? We would actually recommend sanding strictly with the grain of the wood. So, with this sample workpiece, the grain is going this way, so I would strictly sand in an east to west pattern back and forth and ensure proper coverage. I would never go against the grain in a north-south pattern in this instant. Let me demonstrate what I'm talking about. This technique would ensure proper coverage and an optimal final finish. The last sanding technique and tip we want to go over is using the correct grit sizes as well as the correct orbit. Looking at the table in front of you, this serves as a nice general guideline for matching up the grit with the corresponding process. Your 80 grit would be for your rougher removal. As we progress up to our 100 to 150 grit, we're talking about our general cleanup. We then go from our 150 to about 220 grit. That's your final inspection and touch-up. And then finally, your final stage, or for your ultra-fine sanding, we're talking 220 to 320 grit. On top of this, we want to make sure that we match up the correct orbit. Dynabrade offers 3 different orbits. 3/8 orbit, your most aggressive, 3/16 orbit, your general purpose orbit, and by far the best seller, and then finally our 3/32 orbit, which is for our ultra fine sanding. Matching up both the correct grit size and the correct orbit will ensure that we avoid swirl marks and get that desired finish. The final thing we want to accomplish in this video is to establish a checklist that you, the distributor, can walk into an end user with and actually diagnose some of the potential problems if they are encountering swirl marks. What you're going to notice is that this checklist, each component falls within the 4 main categories we've discussed today. Again, those 4 main categories of why an end user might be getting swirl marks. 1, problems with the backup pad. 2, properly maintaining the orbital sander. 3, the air delivery system. And 4, proper sanding techniques. Okay, so let's establish this startup checklist. First, let's examine the orbital sander prior to even plugging any air into it. Is it missing any parts, such as the muffler? What is the condition of the backup pad? Is it damaged? Next, let's check air pressure and air volume. Again, with air pressure, all Dynabrade tools are rated at 90 psi while the tool is running. Also, we recommend running our Mega Flow plugs. Next, let's look at the air hose. Are there any tears or leaks? Again, the air hose should not exceed 20 feet in length. At this point, we are drastically decreasing air delivery. We recommend running Dynabrade's new 5/16 inch gray hose to get adequate airflow to the tool. Next, let's look at the grits the operator is using as well as the orbit on the orbital sander. Let's make sure this is matched up to their process so they get that desired finish. Lastly, let's check for proper sanding techniques as we've discussed in this video. Let's take this one step further and look at the advantage to teaming up with one of our Dynabrade territory managers. All Dynabrade salesmen are equipped with what we call the performance assurance case. This case allows us to go into an end user and actually perform a free audit on their air system. What's more, this leads directly into Dynabrade's new cost savings program. We're able to quantify this extra value that we bring to the end user. The mission statement of this video was to make your job easier. I hope you found it beneficial. And remember, a perfect finish begins and ends with Dynabrade.